Hi, Assalamualaikum and good evening. I'm Muhammad Syafiq bin AZRIN. Today I'm going to present on my project, which is the development and study of driving simulator, analysis of steering control. So we're going to continue to chapter 1, which is the introduction. So the general background of this project is from one of the general background is from World Health Organization, which is the WHO. So WHO have data on how many deaths per road traffic incident, which is quite high, 1.35 million in 2016. So this is the charts from WHO, as you can see. Our background of study is the driving simulator. So driving simulator is a great tool for simulation to simulate a driving behavior without creating hazardous environment. So our problem statement is the distraction and lack of focus were some of the reason on how road accident happens, but how much depth of knowledge do we have over the situation? Most of the related situation can cause to extreme damage on the vehicle and fatal and for the driver and passenger. So not much of data we could collect post-incident for future references and improvement. Hence, by developing a driving simulator, how much data can we obtain from a simulated hazardous driving scenario? So this is some of the NHTSA infographic poster. NHTSA stands for National Highway Traffic Safety Administration, which is an administration in the United States of America. So the objective of this project is to develop a driving simulator that can give out steering performance data. Then to develop a simulated scenario that can be dangerous to be tested on a real road situation. Finally, to study and investigate if driving with speed under certain scenario that require cornering or evasive vehicle maneuvering can affect the driving performance. So the scope for this project is the simulation experiment is limited to static simulator, as that is the only simulator available. The maximum amount of participant is 11 person. Then participant is limited to young drivers, which is 18 and above and below 30 years old. The data that will be studied from the simulator is the input data of the steering that will be used by the participants. So we're gonna continue to chapter 2, which is the literature review. So we're gonna have a quick glimpse on the past study. So of course the overview. Basically our past study on driving behavior, reaction time, road safety, and of course the simulator itself, the driving simulator. So we're going to continue to chapter 3, which is the methodology. So of course every project begin with project planning. So some of the plan consists of materials gathering, driving simulator research, and making project flow charts and Gantt chart. So for driving simulator test, the experiment design is it will be divided by 3 tasks, and these tasks are evaluate driving simulator steering performance and behavior. So the focus is to analyze the steering control. So the first task is the cornering track. The cornering test, which is a track with 4-way intersection. So this track is a closed circuit, like the number 8 track with an intersection. So it will test and observe how a person take a sharp 90-degree corner. Second test is an obstacle test. It will evaluate driving simulator steering performance when avoiding an obstacle. So the third task is lane changing task. It will evaluate driving simulator steering performance when changing lane. Then to develop test scenario for this project, Bmmu.drive, which is the simulation software or simulator software, was chosen for the simulation. Steering output data will be analyzed and compared to every participants. So from Bmmu.drive, they will give out the data log for how much the steering input was given. So this is the cornering test procedure. As you can see, for the left turn cornering, the car will move from 1, 2 and 3. So for the data log, we will extract the data from the number 2 part, which is when it begins cornering and it ends cornering. Same as the right turn cornering. The data log part we will be extract is from the beginning of number 2, which is when it start cornering, and to the end of number 2, which is they begin to move straight. So the next test is the obstacles test. So the obstacle test, as it names, is to avoid obstacle. So the car will drive in a straight line or straight road, and then an obstacle will be there, and they need to avoid this obstacle. So as you can see, at number 1, we will start taking data at number 1 and stop collecting it at the end of number 2. So that's the place where the data is taken, which is same as the cornering test, the beginning of the avoid maneuvering and the end of it. So as you can see, the situation for avoiding to the left is quite the same too. And then the third test is the lane changing test procedure. So for lane changing, it will be done continuously, which is it will start at number 1, where the car drive on straight line and pick up the speed. So during number 2, it will start changing lane. So during the beginning of lane changing, when they start shifting the steering wheel, the data from data log will be taken out from there, and just before they start to move straight again. And that's number 2 is how they move to the right or changing lane to the right, and number 3 is changing lane to the left, and the process is similar to the data collection is pretty similar to the number 2. So chapter 4, we're going to continue to chapter 4, which is the result and analysis. So this chapter presents the result and analysis of the development of driving simulator and the data it can harness for the research purpose. The raw data that were obtained from the simulator data log are to be processed and calculated by the help of Microsoft Excel. So we use for this project, Microsoft Excel were used to analyze the data. Tests that were involved with 11 participants are performed to demonstrate the applicability of the proposed system of the driving simulator. As the objective, we want to know, this project is to show what can we obtain or information that can be obtained from the simulator itself. So before that, the first analysis this project done is the steering angle analysis. So of course, the steering control is the Thrustmaster TX racing wheel. So to skip this part, we're gonna explain that the data output from the data log will be given is around the value 1 and 0. So it will move from 0.1 and below, and will move up to 1.0. So 1 represents 100%. So in the end, all the results that were obtained from the data log will be times by 100%, or the angle itself, to find the real angle of the steering wheel. So the initial analysis for participant steering handling behavior. So this is the initial analysis based from all the participants' data log and all the tests they have been taken. So this analysis is by participants. As you can see, this is the curve of the steering, which is the left. The value is negative because negative represent the anti-clockwise movement, and positive, of course, present the clockwise movement. This is the result of the corner test analysis. So as we can see, what can be found here is the quicker we take a corner, the higher the average steering angle we use, or the higher the maximum steering angle we use. So this is the corner test analysis. The trend can be shown here from the scattered graph. So we taken the average maximum steering angle. So as you can see, for the left and right, when longer times are taken, the less steering angle it takes, and when less time it taken, the higher the steering angle it has. This is the obstacle test analysis. As you can see, obstacle tests have lower average time, which is because the car move at high speed. It give out the pretty same result, which is the lower the time taken to do the maneuvering, it will give out the higher steering angle. And this is the result and data from the lane changing test analysis. So left turn, of course, another scattered graph. Each of the result demonstrate a pretty similar pattern, which is the lesser time you take to cornering, or the quicker you cornering, it will take higher angle of the steering wheel, which is will turn the steering wheel much more, which is not very safe. So we're gonna continue to conclusion. Well, the number of road accidents and fatalities is currently still high globally and locally. Reaction time is important during driving and could be the key to avoid accidents. Certain behavior or action during driving could cause a reaction time. Initial result prove that the average reaction time that were obtained is correlate to some past study. And driving simulator research could obtain more result from a safe environment. For me, that's the conclusion we had, that answered the objective that we trying to achieve, which is to obtain result from a driving simulator and create a dangerous scenario. So we obtain the project obtain result without risk any casualty or injury in a safe environment. And that's the purpose of this project, which is to create a safer environment to study dangerous driving behavior. So that's all for me. Thank you very much.